thinking. Does it matter? Should we use low, medium, high, extra high? Mr. Matt Pocock, aka Snake Skill Salesman, came out with an absolute heater, and he dropped this tweet, and I want to go through it. When they're playing with the effort dial, people seem to start high and go low if they need to. In my opinion, this is a crazy way to do things. You should start low and only go higher if you need to. And so he's arguing that we should ramp up our thinking level as we go. Instead of starting off immediately at the tippity top, we progress as we work. And so instead of going straight into a full sprint, you might start off with a low reasoning. Now the benefits to low reasoning are obviously faster. This is probably the biggest benefit, but also cheaper, right? These are two unanimously great benefits. However, as always, there is a cost, and that cost is accuracy or effectiveness, or however you want to coin the term. Because if we boil it down, the LLM is effectively predicting our next token, right? If we say blue, it's going to predict what we're going to say next. Maybe it'll be red, maybe it'll be green. And so what happens in layman terms, as we go down into the reasoning, we increase the time spent inferencing. And so let's model this here. Actually, this would be flipped. And so as we increase the thinking level, the time spent inferencing goes up. Now, every lab has their own way of doing this part. And so this is part of the discussion I want to get to, but just keep this in mind as we read through Mr. Matt Pocock's line of thinking here. So he goes on to say, effort is essentially throwing more tokens at the problem. This works great in benchmarks, where spending an extra 20% yields a 2% improvement, which is great for marketing. Keep in mind, there are diminishing returns here, right? There's a reason why most models, they recommend a medium tier, and then they'll recommend the higher for more advanced types of work. And so Mr. Pocock is arguing that it makes sense for benchmarks to go, all the way cranked up where you want the best result. There are benchmarks where you will not get an improvement by increasing the thinking. There's a paper here called Does Thinking More Always Help? Understanding Test Time Scale in Reasoning Models. So they highlight here, our investigation reveals that the initial accuracy gains from test time scaling up to some average thinking tokens are largely an illusion, arising from randomness rather than the model's refinement. Slot machine. This observation further implies that the wait and think more approach is not an optimal way to utilize the test time thinking budget, which leads to a fundamental question. Given a fixed thinking budget, how optimally allocate resources for test time scaling in reasoning models? Key finding is that while extended thinking initially improves accuracy, continued reasoning beyond a threshold degrades the performance, a phenomenon we term overthinking, right? So this claim here of them always wanting to do this, obviously that is not true. But the main thing Mr. Pocock is highlighting is that in regular tasks, such as exploring a repo or modifying a test, it just means burning pointless tokens. Right? So if we take this in isolation, I agree with it. I think there are a lot of cases where you do not need the highest thinking model. Something like making a modification, which you're going to target anyway, right? You're going to tell it explicitly what to do, and then also just pure exploring a repo. However, even in this case, there are some nuances, which I'll get to. And so this paper shows that it's not always about higher thinking when it comes to benchmark, which, it seems like it would support his argument, right? His argument is that we don't always need the higher thinking. But the reason I mention that in relation to this tweet is that he's making it seem like it's purely a marketing benefit. Right? As we mentioned, lower thinking levels, we end up with a faster and cheaper solution. But guess what? It is this part here that is worth mentioning. Just because it's cheaper, you should consider what you're losing, right? The accuracy and the effectiveness part. When you're window shopping for something, typically you're thinking about these things, right? You're thinking about long-term usage, reliability, that kind of stuff. The LLMs, right? You need to think about, okay, well, if I go with lowering it down to low, what am I sacrificing? I'm sacrificing accuracy and effectiveness. And so while the examples he gives here, right, exploring a repo, modifying a test, these are good examples. However, you could argue that you might end up with some hallucinations, even exploring a repo. And so when you use a low model to go through a repo, there's a chance it's going to come out and it's not going to have everything as clearly laid out. If I have a repo here, if I hammer this thing with a low param or a low thinking level model, right? Let's say it spends just a few seconds on inference. Depending how big this repo is, like let's say this is a 100K line of code repo. Now obviously, but even this isn't a good example, right? Line of code is the worst metric of all time, right? There could be so much complexity in this repo. And so using a low reasoning repo, it might make sense for something simple. Like let's say this is just a freaking Python file that's just a few files and it's not using any advanced unknown frameworks. This might be fine, right? It might come out and give you a good output. But if we're assuming that this is a very advanced repo, right? Convoluted, complex, many cross-functional components, all of this stuff here makes it so this low might get you something misleading. And so to say that it's always better for reading repos is also not quite a line. And what he's not considering too is how hands-on the engineer is. If you're a really hands-on engineer, there is a difference in the model thinking level, how it will impact you. If you're somebody who's hands-on and you really have a good understanding of the repo before you even do this operation, what you're likely to do is provide a good prompt before it goes and does its operation, and it's going to increase the chance that it doesn't have a misleading output and it ends up being good. But this has nothing to do with you as an engineer, right? This is just a reality. Sometimes you're going to run into these repos, and oftentimes when you want to do this, you're not familiar with everything. And so if I send a low thinking level model on this 100,000 line code, obviously you don't want to do that, but if I were to do that, it would probably give me some misleading results. That's just a reality. And so there's really a lot of nuances when it comes to the thinking level. And he goes on to say, right, this is especially true in Fable class models where tokens cost so much more. Right, we are seeing the token costs are quite high at these higher thinking levels, but really there's a reason for it. And the more tokens you burn, the faster the attention degradation creeps up and the worse your tokens become. Kind of contradicting what he's saying, right? Because he's telling you that you can get away with a low model, but then he's telling you there's risk of degradation. This is literally a result of using a low model, right? If you use a low model, you're basically accepting this fate immediately at the onset. And obviously he's also not considering the skill of the engineer here. If you're a good engineer, you're not gonna waste tokens in this way, right? There's a lot of things you could do to reduce your token usage, right? Managing your context window, being clear and concise in your prompt. And so if you're a skilled engineer, yeah, you might be able to just use that extra high model and not use up a shit ton of tokens with a super high thinking level model and it not be expensive just because you actually put effort into your prompt. And he goes on to say, people are a little too convinced by these graphs that show quality line going up when you increase the effort. So they think, oh, I'll try this out on extra high, but not on max. That seems reasonable. Now, I think the problem here is assuming any benchmark is worth looking at anyway. I think all benchmarks are absolute dog, and really you should not consider any of them to be good, right? So my take here is don't look at any graphs at all because benchmarks for LLMs are just a cesspool of bullshit. If it works today, it's not going to work tomorrow. Don't look at graphs at all. How about that? But what he's saying here, right? The graphs make it seem much more so. And of course it does, right? They want you to spend more money on their tokens if they can, right? And he goes on to say, but those graphs hide the cost, the latency, and the unbelievable waste. I mean, there's a lot of things these graphs are hiding, right? There's definitely a lot of things. Anyway, he concludes his argument by saying, if you ever ask the agent to explore your repo and end up with 200K tokens spent, you know what I mean. So whenever you're trying a new model, try the lowest effort level first. If you see a dip in quality, creep up. First of all, again, getting back to the skill of the engineer, I think this part here is on you. When you're doing engineer work, it is on you to make the right choice when it comes to how you're using the LLM. If you're having your LLM just go buck wild on your repo, that is a bad idea. Like the worst prompt you could ever send to an LLM, I think, is find this thing. Something super basic that has no direction at all. You want to be sending something like, hey, find feature A. Ideally, you have the exact name so it can just find it easily through grep. And ideally, you're giving some kind of file path, right? There's so much things that you could do to reduce this. And you could argue too, you could end up in this situation with a low model, right? If you sent a really shitty prompt to a low thinking model, eventually it's going to creep up. And also the thing he's not considering here is the technical debt associated with picking a shitty model right out the gate. Low thinking creeps up on you, dude. Every mistake that this low does adds up over time, and you may not realize it right away, right? It might take a few prompts. You might send 3 prompts on low and everything looks good, right? You're testing it out and everything checks out. But then guess what? You find out there was something weird it was doing, and now it's too late. Now you're down here and you're stuck using low and it doesn't work. So what do? You go and you try to use it on high. You're like, okay, this doesn't work. Let's use Matt Pocock's advice here. Let's ramp it up to medium. Okay, that didn't work. Let's ramp it up to, right? You're going to keep going down the line like Mr. Pocock says. And unfortunately, you end up with a lipstick on a pig situation where your entire code base has been built off the bricks of low thinking, and it's possibly misled to now you're going to have to spend even more tokens to correct all of the bullshit that just happened in your code base. So I think his sentiment is there, right? It's like, hey, you start low and you increase it. But by the time you've increased it, it's too late. You've already ruined your freaking code base because you spent so much work on using a low thinking model. And so I'm of the belief that the answer is way more nuanced than this. And in my opinion, this is so misleading that I don't think that this is the advice somebody should ever give out. In my opinion, choosing the thinking level is a skill in itself. And I'm not talking skill MD, I'm talking human skill. You as an engineer should be able to evaluate where each model and thinking level applies. If I'm building a sandcastle, sure, I might go ahead and use a low model because it's not that important. Right? At the end of the day, it's sand. It's not going to ruin my entire budget But if I'm building an actual castle, you best believe I'm going to prioritize a little differently, right? I might choose a different model, different thinking level. And so it's important, really the advice should be, choose the best tool for the job. Or in this case, choose the best thinking for the job. I don't believe it's always better to start off on low. I really don't. I think you're better off in most cases, I would argue, most cases you're better off starting with medium. And actually, I would say this should be where you are 99% of the time. There's a reason all the labs recommend medium, is because that's usually the best bang for the buck, right? You're getting a good enough accuracy without charging a bajillion dollars, and the speed's good. And so really, if anything, he should be saying, hey, start off on medium and creep it up. Low is a very specific case for most models. Low is for speed, non-important thing. And to be honest, I use low a lot. I would say for me personally, I use medium the most, low the second most, and then high the third most. And so I'm typically using low when I want something explained to me, if I want it to parse something that's not too integral, but I'm rarely ever using low for anything important. And I'm especially not using high for everything because it's fucking expensive a lot of the time. And so really, I think the advice here is more nuanced. I think you can't just say, oh, we should just all use low and then creep our way up. I think that's a really unengineered way to think about things. And he mentions, right, if you see a dip in the quality, creep it up. Dude, if I'm shot in the arm, I'm already shot in the arm, right? Once you realize that you've been shot, it's too late. You can't just undo Control Z the bullet, right? And so you're going to end up in this case where you've accumulated tech debt without even realizing it, right? Because this isn't always obvious. Like I said, you might send a low, and every result seems to come back good, the test path. But then you'll find out there's some nuance that it just didn't catch up on. You're risking missing nuances every time you send one of these. And I know damn well you're not reading every line of code. Nobody's reading every line of freaking 10,000 AI-generated code. And so my advice, stick to medium, ideally high. Right, this depends on the model. Some models are really, really effective at medium. Some you should use high. I would say with Stable, for instance, high seems to be the better option. Right, yeah, you technically are spending more in and out, but the output is more consistently better, and you're running into less having to go backwards. Right, you have to realize there's a token cost here of having to go backwards because now you have to fix the shit that broke. And so my advice here is to stick to medium. And if you are a rich boy or do not care about token cost, just stay on high, dude. Use low for speed. Use low for non-important shit. Use medium for everything else. Use high if you are really, really, really scared, right? There's times where if it's something that's going into production and it has high impact, I would not even, I would just always assume you want to use high. But maybe there's another case, right? And really you have to learn this yourself. You're not gonna, nobody can just tell you. Matt Pocock likes to go online and act like, oh, you can just download my one skill and it'll solve all your problems. But unfortunately, the real answer is this is something you have to learn on your own, right? Every project that you do, you kind of get a taste of what model does best and what thinking level does best for each task. And you'll build up a skill set that lets you understand when to avoid using something like low and when to prefer using something like medium or high. Anyway, the only reason I made a video on this is because I think it's a dangerous recommendation to give. If somebody takes this at face value, they're going to use low all the time, and they're going to end up in a bunch of technical debt soup salad that they now have to go back and correct with a high reasoning because it's a mess.
Matt Pocock, course salesman, 23,000 stars.
100.
I'm going to show why it's
Really cool.